Okay, so another example. This is 8-19, and here we have a slightly different situation going on, and there's a couple of things that are interesting. So let's go ahead and take a look at this example. This is on replacing $1 bills with $1 coins. So let's read the problem. It says a statistician read that at least 77% of the population oppose replacing $1 bills with $1 coins. To see if this claim is valid, the statistician selected a random sample of 80 people and found that 55 were opposed to replacing the $1 bills. At alpha equals 0.01, test the claim that at least 77% of the population are opposed to change. Okay, so let's go ahead and pause and collect our pertinent information for this problem. All right, so just going back through the text of the problem, it says at least 77% of the population oppose replacing the dollar bill. So here our hypothetical population parameter is 0.77. Okay, we are going to use Q for this one. We're going to do 1 minus 0.77, and that will be 0.23 for Q. Right? The way that we get P hat is we do X divided by N. So this one we actually have to calculate. Some of the problems actually go ahead and provide us with P hat, but then from there we have to derive N or X sometimes. But we were given 55 people opposed it out of a sample of 80 people. Yeah, and then so dividing 55 by 80, we get and so after doing this division, don't do it by hand. That's silly to do long division by hand on paper. Just do it on the calculator, 0.6875. So one kind of interesting thing to notice here is the sample statistic and the population parameter that we have hypothesized here. It looks like it's going to negate this claim. It looks like it's saying that it's not as high as 77% that oppose this. Okay, so the last thing about this was what? Alpha is 0.01. Okay, so that's the significance level that we're going to be using here. All right. So the second thing of interest to notice here is the verbiage that it uses. It says the statistician wishes to see if at least 77% of the population believes this is the claim. All right, so, couple of things about this. This is a little bit different than we've seen in the past. For example, if they say we think that it's less than 77%, well, that's a left-tailed test, and that's what we're looking at there. All right. If we want to say, okay, look, we think it's greater than 77%. Okay, that would be a right-tailed test. That would be over in that region there. Okay, for the case of a two-tailed test, we're just saying it's not equal to, right? So our rejection region, where it is either less than in this direction here, or greater than over here, is our rejection region. So notice that means by default what is left over, this region in the center here, that basically, if we land in this region here, we're basically going to say, whatever the rejection region is, whether it's on the left or on the right or both, if we're in the center, we're not in the rejection region. And so we never prove the null hypothesis, but if we're not in the rejection region, we at least are going to not reject it. And so if we don't reject that claim that it's equal to 0.77, that means we're in this region here in the center. So essentially what we're saying is we want our test statistic to land somewhere in here, okay? If it's in the center region, that would indicate that it's close enough to 77% that, who's counting? We'll take it, all right? Or, well, let's see, if the statistic says it's at least 77% that oppose it, and we find that the true population parameter is 90%, well, that would be at least 77. So basically, what we're going to do is a little bit unlike what we've done in the past, because we're going to say, well, if it's in this zone here or in this zone here, right? As long as it's just not on the left side here, we'll go ahead and believe that previous statistic. All right. So notice we are actually going to set this up slightly differently and use a left-tailed test for our rejection region. Okay. So let me summarize that here. Our steps. Step 1, H subscript 0 is to state that our proportion is equal to 0.77. Okay? And that's our claim. And when we get down to step 2, I'll re-explain why that is. In H subscript 1, well, we're going to negate this. And we're going to negate it in the way that's pertinent to our research. We're going to say P is less than 0.77. And again, I'll make more detail about that in the picture here. Okay? All right. So here we are. Here's our Z distribution, basically. And we're going to say this. Look, if we are in the rejection region here, that means that the true proportion is significantly lower than 77%. And so if we reject the null hypothesis, we're essentially saying, it's not true that it's 77%. And since we used a left-tailed test, then it doesn't matter whether it's over here, or over here, or even if it's way higher than 77%, then it would still be at least 77%. So that is why we're going to use, for our rejection region, for an alpha value of 0.01, that is a critical value of what? Gotta look that up. Let me pause. That is a critical value of 2.33. Sorry, negative 2.33. And funny thing about the Z distribution is we keep getting the same test value over and over and over and over and over again. Okay, so let's move on to step 3. Step 3 is we'll compute our test statistics. So z, we'll do that by z is equal to p hat minus p, all divided by the square root of the whole thing, p times q, all divided by n. And that is all happening inside that radical there. Okay, so we're going to plug in 0.6875 for our sample, all right? And here's 0.77 for the hypothesized population proportion. We're plugging into this radical here. We've got 0.77 for P, 0.23 is what Q has to be, and we're dividing that by our sample size, which is 80. And so turning to the calculator, we get negative 1.75. All right, and so, well, I don't want to have to flip back to the previous page, so I'll just re-sketch the distribution. There was our cutoff, or our critical value, negative 2.33. There's our rejection region area underneath the curve, 0.01. Okay, and our test statistic, negative 1.75. It's right there. So notice it's not within the rejection region. So it's kind of interesting to note here. Our sample statistics, 68%. Not even not even 69% opposed the switch to the $1 coin. All right. So that seems like it's a lot lower than 77%. It seems like the evidence contradicts what we're saying. So even though our z value, our test statistic, is negative. See, there's 0, and here's our test statistic. It's not negative enough. It's not way over here in this rejection region that would cause us to say that the true proportion is significantly less than 77%. Okay? So basically, it's kind of like a roundabout way that we're approaching answering this question of is the true proportion at least this amount? We're going to say, well, as long as it's not less than that, we know it's at least. So we kind of have to like prove it a little bit backward. Right. At any rate, step 4. Step 4 is we make the decision. So here we again fail to reject the null hypothesis. So we fail to reject the null hypothesis, and therefore there is not enough evidence to say what? There's not enough evidence to say whatever it said in H subscript 1. In H subscript 1 we said P is less than 0.77. So here we don't have enough evidence to reject the previous claim that at least 77% of the population opposed the change, because we've found that our sample is close enough to 77% so as to say that, hey, yeah, if it's 77% or higher that oppose the change, then at least 77% oppose the change. So we have essentially proved our claim. We didn't prove the null hypothesis, we just simply could not reject it. All right. So that's why that one looked a little bit different. We'll go to the p-value method, and then we'll conclude our lecture for Chapter 8, Section 4.